Hello everyone, welcome to this video. In this video, we are going to learn about Theil Sen using OpenMathAI. So, let's get started. What is Theil Sen regression? Theil Sen regression is a supervised machine learning algorithm used to predict a continuous numerical value, just like linear regression. However, unlike linear regression, Theil Sen regression is designed to handle outliers, making it a more robust model when the dataset contains unusual values. The main difference between Hubbard regression and Theil Sen regression is how they deal with outliers. Hubbard regression uses a special loss function. It treats small errors like linear regression by squaring them, but for very large errors it switches to using the absolute error. This reduces the influence of outliers during training. Theil Sen regression, on the other hand, does not use a special loss function. Instead, it calculates the slopes between many pairs of data points and chooses the median, middle, slope as a final regression line. Since the median is not greatly affected by extreme values, outliers have very little influence on the model. Imagine you want to predict the price of a house based on its size. Most houses follow a normal pattern where larger houses have higher prices. However, suppose two or more houses with a size of 2,000 square feet and 12,000 square feet. Size instead of its 10 are listed at a much lower price than other houses. These are outliers. Theil Sen regression reduces their effect by using the median slope instead of relying on all the data points equally. Because of this, Theil Sen regression is often more robust when there are multiple outliers in the dataset. We will use this dataset for the Theil Sen regression model, so let's get started. Open OpenMathAI. In this demonstration, we use the house price prediction using Theil Sen regression model. Click Create New Project. Enter the project name as House Price. Choose a folder location to save the project, then click Save. To import your dataset, either click Load Example Dataset or browse for Dataset to import your own CSV file. Once the dataset is loaded, verify that it contains all columns before proceeding to model training. Scroll down to view the first 10 rows of sample data. Click Continue to Configuration to proceed. Configure the dataset by specifying the input features and output target. There is also a feature called Ignore, which can be used for columns that should not participate in model training. Select the input and output columns manually, or use Smart Suggest for automatic recommendations. Review the selected configuration. Click Proceed to Model Design. Choose a model from the available machine learning models. OpenMathAI recommends suitable models and features based on the dataset. For this demonstration, select the Theil Sen model. View the model overview, pros, cons, and real-world applications. Click Proceed to Training. You will see the selected model. Click Start Multimodal Training. Review the training configuration. Test Data Split, which determines a percentage of data reserved for testing and validation. Review the model parameters and pre-processing settings. Modify the configuration if required. Click Start Training to begin the training process. After training is complete, review the following performance metrics. R-squared measures how well the model explains a variation in the output data. Range 0 to 1. MSE, mean squared error, measures the average squared difference between actual and predicted values. RMSE, root mean squared error, the square root of MSE. RMSE is expressed in the same units as the output variable, making it easier to interpret. Engine time, the time required for the generated model engine to execute and produce predictions. Lower engine time indicates faster model execution, which is important for embedded systems and real-time applications. Fit quality, an overall assessment of how well the model fits the dataset. It is generally derived from metrics such as R-squared, RMSE, and residual errors. Model accuracy. For regression models, accuracy is commonly estimated using the R-squared value. Example, R-squared equals 0.95, accuracy almost equal to 95%. Click Math and Code Preview. View the generated mathematical equation and source code. OpenMathAI provides expression of the data, detailed explanation of the expression, and an implementation code. Return to the results page and click Deploy Status. Click Export Model. Choose the required export format. Answer C. FMU 2.0, FMU 3.0, Python bundle, ONNX hub. Select the destination folder for the exported files. In this demonstration, select ONNX hub. Click Deploy Engine. In the professional version, OpenMathAI can also generate PowerPoint and PDF reports. Now, let's see how to execute the exported ONNX model. Before running the model, make sure your system has Python, NumPy, and ONNX runtime installed. Next, open the example_inference.py file. If you want to test a model with different input values, you can either edit the input values directly in the file or replace them with the input function. Using input allows you to enter the input values each time you run the program. After making the changes, open the command prompt in the exported folder. Run the following command: Python example_inference.py. The program will load the ONNX model, enter the input to and press enter, and display the predicted output on the screen. This confirms that the exported OpenMathAI engine can be successfully compiled and executed on ONNX.